Welcome to this session. This session, we are going to evaluate some determinants using the properties we stated in the previous session. So yeah, there are two problems. Okay, fine. So let's solve the first one to prove that the determinant given is 0. So solution. So we have to show that the determinant b minus c, c minus a minus b, c minus a minus b, b minus c, a minus b, b minus c, and c minus a, we have to show that this determinant is 0. Now, if you check clearly, the elements of this matrix are formed by letters A, B, and C. So we can say, let column 1 to be column 1 plus column 2. And let's keep column 2 and let's keep column 3 in this step. So that we'll have, now when I add B minus C plus C minus A, I'll get B minus A, because C minus C plus C is 0. And then C minus A plus A minus B is C minus B, because minus A and A cancels out. A minus B plus B minus C will be A minus C, because minus B and B cancels out. And here I have C minus A, I have A minus B, I have B minus C, and I have A minus B, B minus C, and then C minus A. Remember, adding a scalar multiple of a column to another column doesn't change the value of the determinant. Now, in the next step, I'll say I take column 1 and then I add to column 3. So by doing that, I'll have determinant of now B plus, so B minus A plus A minus B is 0. So I have 0. C minus B, this element here, plus B minus C is also 0. A minus C plus C minus A is still 0. So I have 0 here. And this, I keep column 2, I keep column 3. So I have C minus A minus B, B minus C, A minus B, B minus C, C minus A. And you see, whenever we have a column or a row that has all elements being 0, then the determinant is 0. So therefore we say this is 0, since all elements in column 1 are zeros. So that's how we prove that one, first question. And then question 2 was without expanding, evaluate the determinant. Sine alpha, sine beta, sine gamma, cosine of alpha, cosine of beta, cosine of gamma, and then sine of alpha plus delta, sine of beta plus delta, sine of gamma plus delta. So we have to evaluate this determinant. Now, this is an interesting problem which assumes that you already have concept of trigonometry, especially the double angle formula. So recall that. So this is the determinant. Let's call it delta. Sine A plus B is the same as sine A cos B plus cos A, and then sine B. Now, which means that sine of alpha plus delta is the same as sine alpha cos delta plus cos alpha sine delta, and then sine of beta plus delta is sine of beta cos of delta plus cos of beta sine of delta, and sine of gamma plus delta will be sine of gamma cos of delta plus cos of gamma sine of delta. So I use, let me call this one star. I use star to rewrite these terms of the third column. So using star, delta becomes, so I'll have delta is determinant of sine alpha, have sine beta, I have sine gamma, and then cos alpha, cos beta, and then cosine of gamma. So this will give me sine alpha cos delta plus cosine of alpha sine of delta, and then sine beta cosine of delta plus cosine of beta sine of delta, and then sine gamma cosine of delta plus cosine of gamma sine of delta. So that is by use of the double angle formula. Now, the next step, after replacing those at the third column by the respective expressions for double angle formula, then we say let column 3 to be column 3 plus minus what plus? Column 3 minus cosine of delta times column 1. And let's keep column 2, and let's keep column 1. So we are saying that we are rewriting our third column in such a case that we are multiplying, or we are taking column 3, then you subtract cos delta minus column 1. So this determinant will be, remember, by doing this, it doesn't change the value of the determinant because we are simply adding a scalar to another column. So column 1 will be sine alpha, sine beta, and then sine gamma. Column 2 remains to be cosine of alpha, cosine of beta, cosine of gamma. Then now let's see. Column, this we have sine alpha cosine of delta plus cosine of alpha sine of delta. Now, when I subtract, column 1 times cos delta will be sine alpha times cos delta. So this and this cancels out. So I remain with cos of alpha sine of delta. So at least now I don't have a sum of two, I just have one term. Now, next, I take sine beta cos delta sine beta cos delta plus cosine of beta sine of delta. I subtract cos delta times sine beta. So I have sine beta cos delta. So this and this cancels out. So I remain with cos beta sine delta. Similarly, this will be sine gamma cos delta plus cosine of gamma sine of delta minus cosine of delta times sine of gamma. So this and this cancels. So I have cosine of gamma sine of delta. So this is the determinant that we'll have. Now, next, we still play with this column 3. So we say column 3 to be column 3 minus, now we say sine delta of column 2. Sine delta of column 2. So column 2 remains to be column 2. Column 1 remains to be column 1. So delta will be determinant sine alpha sine beta sine gamma, and then cosine of alpha cosine of beta cosine of gamma. Now I'll have this one will be cos alpha sine delta minus sine delta times cos alpha will be same as cos alpha sine delta, and this will give me 0. So I get here 0. Now here I'll have cosine of beta sine of delta minus sine delta times cos beta is cos beta times sine delta, and this still give me 0. So I get 0 here. Here I'll have cosine of gamma sine of delta minus sine delta times cos gamma is cos gamma sine delta, which still give me 0. So I'll have here 0. And when I have a column that has all the elements 0, then the determinant is 0 because of this property. So since all the elements in the third column are zeros. So whenever we have a column that has all the elements 0, the value of the determinant reduces to 0. Thank you.